Distinction between sets and instances. In our last lecture, we have seen that in most of the frame representations, we had an is-a relationship, and in some cases, we had the instance relationship. In many cases, the is-a relationships used to have transitive dependencies that we have seen, right? Now, under which cases we are supposed to use this is-a, and in which case we are supposed to use the instance. That means today we'll be talking about the distinction between the sets and the instances, right? Sets means is a property of a frame or a slot the attribute or a slot in a frame is a subset class relation, right? Whereas the instance is a element of type of a relation within the slots inside the frame, right? So let us see the distinction clearly first. Cardiff RFC, this is what? Now, this is the name of a team. Cardiff RFC is the name of a team. That can be thought of as a set of players, obviously, because it is a team name. So it can be considered as a set of players or as an instance of a rugby team. That means we are talking about instance means Cardiff RFC can be considered as an element of Cardiff RFC can be considered as an element of the class rugby team. So in this case, if we create a frame of Cardiff RFC, then with another frame, if it exists, we call it as the rugby team, then the relationship between the Cardiff RFC and the rugby team must be an instance type of a relationship and not is a class of a relationship in case of frame holdings for slots and attributes. Let us see further. If Cardiff RFC were a class, let's say it is not an instance, rather it is a class, then its instances would have been what? The players, right? But it could not be a subclass of the rugby team. It could not be a subclass of the rugby team. It could be an instance of the rugby team, but it could not be a subclass of the rugby team. Why? See, if Cardiff RFC would have been the instance of a rugby team, means what? Now it is an element of the rugby team. That means there are a lot of rugby teams, out of which Cardiff RFC is one. That means all the players contained in the Cardiff RFC will always belong to Cardiff RFC if Cardiff RFC is an instance of the rugby team. I repeat this statement once again. That means all the players, the set of players that Cardiff RFC holds will belong to Cardiff RFC if it is an instance. That means it belongs to the class of rugby team. That means rugby team does have many rugby teams, out of which Cardiff RFC is one, whose set of players are fixed. That means the players of this team would not go for any other team. But if Cardiff RFC were a class, then its instance would have been players, obviously. But it could not be a subclass of the rugby team, otherwise its element would be members of the rugby team, which we don't want to. That means if we make it a subclass of rugby team in place of instance, then what will happen? The Cardiff RFC's player will be available. That means will be a part of some more teams, which is not acceptable. That means the players will be playing for Cardiff RFC must play for Cardiff RFC only, right? So instead we make it a class of rugby player. Instead of this, that means making it a subclass of the rugby team, we make it a subclass of the rugby player, and this allows the player to inherit the correct properties, enabling us to let the Cardiff RFC to inherit the information about teams. That means now we have secluded the players within a particular team name, which may belong to a higher class or a higher frame segment, not a higher frame, it's another frame. That means rugby team, and its all classes can be subgrouped under the rugby player head. So the rugby player can have all the players from many different teams which belong to the another frame called as the rugby team frame. But by doing so, no, so sorry, this means that Cardiff RFC is an instance of rugby team. So this thing holds true in case of instance. There is a problem associated with this. A class is a set and its elements have properties. A class is a set and its element does have properties. What is a class? Now, Cardiff RFC is a class which belongs, that means which not belongs, which is an instance of the rugby team. And the players which play for, the set of players which play for Cardiff RFC does have properties. That means they are all players. Do we have any discrete properties or unique properties for each of the elements of a particular team? We'll be talking about in the next sentence. We wish to use the inheritance to bestow the values on its members. Now what we expect that the inheritance to bestow, that means to give the values to all its members. But we have to remember one thing, that there are properties that the set of the class itself has, such as manager of a team. What we want to say here is, even if I put up the Cardiff RFC under the rugby team with a particular class value, then it is not necessary that all the elements of, that means all the players of Cardiff RFC will be holding the same attribute or the properties. That means if Cardiff RFC would have been a frame, then its values, that means Cardiff RFC's values are, that means its attributes or its slots are what? Now they are the players. That means everything that belongs to that Cardiff RFC team must have the same inherited properties. Can this thing hold true at all the time? No. A team can have a manager, can have a coach, can have medical people. So this property unanimously cannot be put up in all the elements of a particular team. So what is the solution for this? This is why we need to view Cardiff RFC as a subset of one class players. That means, why we are talking about one class players? That means we are talking about only the players and not the managers or any other employees, those who are working for that particular team, right? So we seem to have a catch-22, or a solution is a meta class. How we are going to solve this problem of inheritance of the properties in case of using instances for the rugby team? Now by applying a meta class. What is a meta class? Meta class, just like that of metadata, it is a class within a class. That means a subclass within the larger class. A meta class is a special class whose elements are themselves classes. That means classes within the classes, what I have said you just now. Now consider our rugby teams. Let's say we are having a few rugby teams out here. Let's see how the frames are constructed under these cases. We are having a team called as the Cardiff RFC, right? Now we will not be going to that part initially. Let's see here. Class. We have defined a class. Class is having an instance of class and having an is-a of class. That means we are talking about class is a subset of class and class is an instance of class. That means class is an element of class. So class is an element of class and class is a subset of class whose cardinality is not required or not defined. Teams, instance is a class and it's also a subset of a class. Its cardinality is the number of the teams that are participating. The team size is 15, inclusive of playing and non-playing. So now I can say that the team again belongs to another frame. This frame belongs to another frame by virtue of its slots called as the class, which has been defined as a slot for another frame called as class. Let's talk about the rugby team. Now the rugby team is a property for team. That means rugby team is a subset of teams. That means the teams can have multiple rugby teams within them. So I'm talking about rugby teams means teams can have multiple rugby teams, multiple football teams, multiple cricket teams, multiple any other team. Within the team we are having the rugby team, which is having a cardinality. That means the number of teams. The team size is 15 and there's a coach which need not be mentioned. We are having, now see what we are doing. We have defined a class to which team belongs. We have defined a type of a team, that means a rugby team that belongs to the class team. Now we are having a particular team name, that means Cardiff RFC, that belongs to the rugby team, right, which is having a team size of 15 and a coach Terry, right. Now we are having a particular player, Robert's instance is back, height is 6, position is this, and team is Cardiff RFC. So if I move from class to team, if these are all frames, let me sum it up gradually. If I do have multiple teams like class, team, sorry, multiple frames like class, team, rugby team, the name of a particular rugby team, and a particular player who belongs to that particular rugby team, the name of that rugby team, that means Cardiff RFC. So moving from class and coming up to that particular player, we can call it as a top-down approach, whereas moving from that particular player upwards via the team name to which he belongs to that particular type of the team, that means rugby team, then to a higher class of team, and after that the team to the class it belongs, we call it as class. If we move it in this way, we call it as the bottom-up approach. So to just revise you once again, we are having a class. Class is having an instance of class. That means it is a component of this class, right? It is a component of this class, or it is an element of this class, right? Class is an element of class itself, and class belongs to or subset of class. Teams instance is class, right? So team again is a component of class, and it is a subset of the class also. After the class and the team, you can see that the rugby team, that means the type of the team when we are talking about, we don't have any more instances. That means within the frames, if we are having slots and the slots have got particular values, particular attributes which holds particular values, then we can say that as we gradually move downwards, we are going to lose the values of the instances and we only hold the is a conditions, right, in general. So what we can see here is that the basic meta class is a class, and this allows us to define the classes which are instances of other classes, and they inherit the properties from this class, right? Inheritance of default values occurs when an element or a class is an instance of a class. Inheritance of default values occurs when one element of a class is an instance of a class. To make the statement true, what it has been done here is class has been assigned a particular instance of a class, and it has been also kept as a subset of the class itself, right, with no cardinality requirement. Fine. So this thing finishes the initial part of frames. Here I would like to draw your attention towards another part. Those of you who would be listening to this lecture, because following all the lectures there will be tutorials. If you are not listening to these lectures properly, you will not be able to answer the questions. We are having a representation of the frames out here, right? We are having a representation of the frames out here, gradually moving from the higher class to its team, then to the rugby team, then to that particular rugby team, and a particular player who belongs to that particular rugby team. If we talk about that, how you are going to represent, this distinction between sets and instances for a particular genealogical tree, as in the case of Adams, then what you are going to do. Now, to make this question much more vivid and elaborate, there are questions related to this thing available on the NPTEL also, right? So my question is that if you're having Adam here, and Adam is a frame, Adam is with Beth, where Beth is not regarded as a particular specific class which belongs to the frame, right? We are talking about a frame called Adam, where this is an attribute of Adam, right? That means Beth is an attribute of Adam, and Charles, Donna, and Alan, they are again the attributes, that means the slots of this genealogical tree representation of Adam. If I now ask you to represent this genealogical tree of Adam in the form of sets and instances, how you're going to do it? This is your question for today, right? I repeat once again, in the genealogical data that has been provided here, in the genealogical tree that has been provided here, that means Adam, Beth, Charles, Donna, and Alan, how you're going to distinguish between the sets and the instances here. While solving these kind of problems, what you got to remember is that you have to check for each and every frame, right? So the minimal amount of frame that is needed to represent each and every slots is 7 out here, right? You have to check that for each and every frame class, are there any classes that can be grouped within that particular frame? That means you can see it here. You can have the sex as male, you can have spouse as Beth, you can have child as Charles, Donna, and Ellen. But in overall representation, you can have Adam, Beth, Charles, Donna, Ellen, male and female, right? How many frames are there? Minimum number of frames? The minimum number of frames that can be made out here is 7, right? The minimum number of frames that can be required here is 7 frames. If here I want to draw your attention that how you're going to make out certain subclasses, that means for ISA and for instance, what you're going to do here? Now, a very clear cut is the child. That means you can put up Charles, Donna, and Ellen in an ISA format, in an ISA relationship for the child, right? Or there are certain situations where Charles, Donna, and Ellen can also be an instance, or Adam can be an instance, or Beth can be an instance. So what you got to do is, you have to assign particular instances and particular sets for this particular tree, and you have to represent them by using the ISA as well as by using the instance form for this particular frame, right? So what you have to do here is you have to draw the all set of frames that are possible for this particular tree, and you have to mention that under which cases you have used the instance and under which cases you have used the set. So this is your task for this lecture today. With this, what you have to do is, this question number 2 is, you have to show a clear-cut distinction between not just sets and instances. The second question is, this is your second question, you have to clearly mention the thin line difference between semantic nets as well as frames. You have to also find out the difference between semantic nets and frames. After you find out the thin line difference or a very minute difference between the semantic nets and the frames, you have to show it by using an example, right? So this is what you have to do. Thank you.